The topic is pyrimidine synthesis. So we'll see how the pyrimidine synthesis occurs. It starts by combination of carbon dioxide and glutamine. Q is a glutamine amino acid. So the enzyme here is carbonyl phosphatase synthesis 2. It is available in the cytoplasm. So it forms carbonyl phosphatase. Then this carbonyl phosphatase combine with aspartate. D indicates aspartate, which is amino acid, by enzyme aspartate transcarbamylase, which forms orotate. Then this orotate is converted to orotate phosphoride by enzyme OPRT to OMP. This OPRT enzyme, orotate phosphoribosyl transferase enzyme, convert orotate to OMP. OMP is orotate monophosphate. Then orotate is converted to this OMP is converted to UMP by OMP decarboxylase. Then this OMP is converted to here split occurs where OMP is decarboxylated by to deoxy sorry, I like to go it back. So UMP is converted to UDP, because as you know, decarboxylation occurs only with diphosphates, not with monophosphate or triphosphates. So that's why UDP it is converted. Then UDP is decarboxylated to decarboxylated UDP, and it can be converted to UTP, from where CTP cytosine triphosphate is synthesized. This DUTP is converted to DUMP, then from DUMP to DTMP. Here T indicates thymine, U indicates uracil. So uracil to thymine occurs only in monophosphate form, and enzyme here is thymidine synthesis. So this is the layout, like how this pyrimidine synthesis occurs. So what are the pyrimidines? We have uracil, so we know how uracil got synthesized. Then cytosine, then we have thymine. So for NEET PG we have to remember the what is the rate limiting enzyme, and then what is the some drugs inhibiting the pathways here. And one more important thing, we have CPS2, like that in mitochondria we have CPS1. Suppose this is the mitochondria. In mitochondria we have CPS1 enzyme, which combines carbon dioxide plus ammonia to form carbonyl phosphate, which goes to urea cycle. So this is CPS1. This is CPS2. So this is mitochondrial enzyme. This is mitochondrial enzyme. This is cytoplasmic enzyme. So as I said, you have to remember which is the rate limiting step. In case of eukaryotes, this is the rate limiting. This CPS1 is the rate limiting for eukaryotes. This is for prokaryotes. So this is eukaryote, this is prokaryote. Then let us see what are the pathology related to this pathways. So we have CPS2, it is a eukaryotic rate limiting enzyme. Then aspartyl transcarbamylase, it is in prokaryotes rate limiting enzyme. So this is inhibited by a drug called leflunomide. It inhibits this aspartyl transcarbamylase. Then we have OPRT. This OPRT and OMP decarboxylase together they are called as UMP synthase. So deficiency can lead to orotic aciduria. It can be type 1, type 2. Type 1 when both this OPRT and OMP decarboxylase are involved. Type 2 is only when either of these enzyme is involved. Only one enzyme out of these two is involved. Then this OPRT, it is inhibited by allopurinol. And this OMP decarboxylase, it is inhibited by 6-azathioprine. Okay, then we have this conversion of UDP to deoxy UDP, it is inhibited by hydroxyurea. And conversion of UMP to TMP, deoxylated TMP, is inhibited by 5-fluorouracil. And one more thing, for this conversion we require reduced. This step is also inhibited when folate pathway is inhibited, like methotrexate, which inhibits this one. And this is essential for this step to occur, because that 5-methyl group is added to the uracil to form the thiamine. So I think you got to know all this.